AI has the potential to be a bigger weapon than nuclear weapons. How do you think about that?
I think it's a bit of a category error there. I mean, a nuclear weapon is an actual weapon. AI is not a weapon.
Welcome to Doom Debates. I'm Liron Shapira. Today I'm reacting to an episode of the 20VC podcast that just dropped with host Harry Stebbings and guest Professor Arvind Narayanan. Arvind Narayanan is a professor of computer science at Princeton University, known for his critical perspective on the misuse and overhype of artificial intelligence, which he often refers to as AI snake oil. Narayanan's critiques aim to highlight the gap between what AI can realistically achieve and the often misleading promises made by companies and researchers. You may recognize that name AI snake oil because Arvind's co-blogger on that blog, Sayesh Kapoor, was featured by me on a recent reaction episode on the question of whether P-Doom is a meaningful claim that should influence policy at all. Sayesh basically said no. I said obviously yes, so I encourage you to go and take a look at that episode. But today we're not talking about Sayesh, we're only talking about Professor Arvind Narayanan. Arvind comes off like what you think of as a cool-headed skeptical guy. He tends to always frame things as like, yeah, this hype is kind of unproven, let's wait and see, we'll deal with things as they come, let's not overreact, let's not trust these hype claims. Very understandable perspective. Of course, as an AI doomer, I think that we're facing an extinction threat, and we do need some level of fear-mongering or hype or expectation that normality will be vastly upended. So you're going to see that clash of perspectives between Arvind and doomers like me. And that's really why you come to Doom Debates, right? Because you know how important it is that we have that clash of perspectives. All right, then, if that's what you want, that's what you're going to get. Let's dive in.
The kind of core question that everyone's asking right now is, does more compute equal an increased level of performance, or have we reached a point where it is misaligned and more compute will not create that significant spike in performance? Kevin Scott at Microsoft says, absolutely, we have a lot more room to run. Why are you skeptical? And have we gotten to a stage of diminishing returns on compute?
So if we look at what's happened historically, the way in which compute has improved model performance is with companies building bigger models, right? So in my view, at least, the biggest thing that changed between GPT 3.5 and GPT 4 was the size of the model. And it was, also trained with more data, presumably, although they haven't made the details of that public, and more compute and so forth. So I think that's running out. I think we're not going to have too many more cycles, possibly zero more cycles of a model that's, almost an order of magnitude bigger in terms of the number of parameters than what came before, and thereby more powerful. And I think a reason for that is data becoming a bottleneck. These models are already trained on essentially all of the data that companies can get their hands on.
Just to review what Arvind is saying here, he's saying, yeah, when we have a bigger compute budget, we typically use it to train a bigger model. And when we train a bigger model, we have to feed more data into it. But the bottleneck is becoming the amount of data available in the world. We don't necessarily have 10x more or 100x more data in the world to feed into the next model. So because of that, maybe having a 10x or 100x bigger model might not improve on the current models because we're close to running out of data. That's just me repeating Arvind's point. But I find that point epistemically sloppy for a couple reasons. My first objection is that he's not giving enough credit to synthetic data. So who cares how much data is on the internet? If more data is really the critical factor here, then what's wrong with different types of AIs that can generate data in different ways? How is that fundamentally worse than random humans generating data? Because if you take half the internet and then look at the other half of the internet, the other half is not that different from the first half, right? It's like, okay, more forums, maybe different topics get mentioned, maybe a few people throw in a few additional facts from these other domains. But like, if you've seen half the internet, and many of us have all seen, our own 0.001% of the internet, and we're not that shocked when we visit different websites, right? It's pretty familiar. So why would Arvind be so focused on how much extra data can come from the internet instead of just saying like, yeah, if you need more data, you can cook up more data to order. You can just have the AI pretend to be a human, but have a type of AI that like simulates something that has like a different type of model that LLMs don't natively reason in terms of. So you're having one AI synthesize a type of data to go feed into another AI, and that'll teach something to the other AI. I'm just saying synthetic data can probably, at this point, help as much as real grass-fed organic data. So that's my objection number one. Objection number two is this idea that data is necessarily going to keep being the bottleneck. If you look at humans like you and me in our whole lifetimes, we maybe get fed in through audio and sight. We maybe get fed in like 1 billion words. GPT-4 got fed in about 1 trillion words. So that's already 1,000 times more that GPT-4 has in terms of wordage than you or I are ever going to get in our lifetimes. So why can't GPT-4 use the words that it got to think really hard and come up with deep concepts explaining those words and just kind of figure out the essence of reasoning and be smarter than us? Why are we still smarter, right? So there's no fundamental reason why that extra word count is necessarily the bottleneck. If we just add more parameters and more kind of brute force, more scale to the transformer architecture, that might be enough for it to quote unquote grok these deeper patterns. It might just be able to start answering questions about a variety of fields just because it thinks more deeply. So for example, you can have a human that is not the most knowledgeable person in the world, but they're just really good at thinking. And so they're just extracting so much out of the data that they've seen because they're making deep connections and they're able to discuss a lot more intelligently than people who only have crystallized knowledge. Right? It's like a lot of us have had the experience of if you have like a contractor or a doctor that's a specialist that you're seeing, a lot of times if you just spend a couple hours on your specific issue, do some Googling, do some reading, and think using fluid intelligence better than the doctor or the contractor can, then a lot of times you become the expert for a minute, right? You have something to teach them just because their crystallized knowledge isn't going to cut it compared to your selectively researching relevant bits of information plus thinking about them better. Now, am I just being uncharitable to Arvind by pointing out the reasons why he's wrong? No, I think he might be right. I don't actually know if he's right or wrong. Here is my beef. My beef isn't that he might be wrong. My beef is that I think that Arvind and people like him keep coming out sounding overconfident. They keep sounding like they have knowledge or insight that they don't actually have. So he's coming out, he's taking a position. He's taking a position that he thinks that LLMs are plateauing because data is running out. What I think very well may happen, it may or may not, I'm uncertain, but I think it's very possible that we get GPT-5 or we get the next generation and it starts passing a bunch of tests that I wouldn't describe as plateauing. I would describe as taking another step toward human level intelligence. And in that case, are the Arvinds of the world going to admit that they were wrong? Have they set out enough falsifiability to their prediction? I suspect what's going to happen is that they will just have a convenient excuse and they'll just be like, oh yeah, there's this new model, but it didn't use the exact transformer architecture. It mixed in these other tweaks. So what I was saying about transformers plateauing, that doesn't count. That's how I think they're managing to sound like they have insight, but they're strategically putting themselves into a position as pundits where they're going to be able to wriggle out of any falsification. I think that's bad for discourse. In my case, if I ever make a falsifiable prediction, I will signpost it that I'm sticking my neck out and I'll tell you how to falsify me. I won't say something that sounds like a prediction, but then leave myself a line of retreat where you can't falsify it. Right now, I'm not making a falsifiable prediction. Generally, what I predict is that once AIs get to human level intelligence, then there will be doom. That's pretty much my only empirical prediction. And yeah, I can give you slight variations of it. Like I think there will be really bad computer viruses maybe a couple years before we get to doom. So I can extend my prediction a little bit. But for the most part, I don't claim to have insight over the next generation of the architecture. That's not what I think is the important issue here. The important issue here is just that we keep crossing the remaining gap toward human level intelligence. I don't claim to be insightful on how quickly we'll cross it or on exactly what it will take to cross it. I'm just observing from an outsider's perspective that one way or the other, we keep crossing it. It keeps getting smaller. So my challenge for Arvind is if you want to act like you're making a prediction, then be very clear about what gets to happen where we can say that you've been falsified. If GPT-5 comes out and it only uses a little bit more data than GPT-4, but it's passing a bunch of new benchmarks that GPT-4 didn't pass, how will you update your beliefs? How will you go back to your blog and say, hey, we've been telling you some things that were false? What's the update you're going to make? Let's clarify what it is right now so that we'll have accountability in our pundits.
While data is becoming a bottleneck, I think more compute still helps, but maybe not as much as it used to.
More compute still helps, but not as much as it used to. Okay. I would like to know why you think more compute won't help as much as it used to, because the reason it's plausible that more compute would help is because it lets you see deeper into the data that you have. It lets you reach a certain threshold of error correction, where if you're given a bunch of detailed instructions, how to follow like a logical program, you can follow it step by step and you can look back and you can double check if you really did follow it exactly because you truly grasp what the instruction meant for you to do at that time. That's the kind of thing that a deeper grokking of concepts can potentially let you do. And that's traditionally attributed to throwing more compute at the transformer architecture. Again, I'm not saying that I know that more compute will definitely help the AI get way smarter. I'm just wondering why Arvind thinks that he knows that it won't, instead of joining me in having a high uncertainty prior. So I'm curious to see Arvind explain the logical reason why he doesn't think more compute will help anymore.
The reason for that is that, perhaps ironically, more compute allows one to build smaller models with the same capability level. And that's actually the trend we've been seeing over the last year or so. As you know, the models today have gotten somewhat smaller and cheaper than when GPT-4 initially came out, but with the same capability level. So I think that's probably going to continue.
Okay, more compute helps you produce smaller models that understand the same data set. But how does that relate to your prediction that more compute won't also help you build smarter models from a given data set? I don't think we get an answer to that. And again, it's fine. It's okay not to have an answer, but I just caution epistemic rigor here when we're talking about whether AI is going to cross the gap further towards superintelligence. It gets to what Eliezer Yudkowsky has called the fundamental question of rationality. What do you think you know and how do you think you know it? Doesn't seem like you're being rigorous about that.
Are we going to see a GPT-5 that's as big a leap over GPT-4 as GPT-4 was over GPT-3? I'm frankly skeptical.
I still haven't heard an explanation of why you're skeptical, besides pointing to a potential plateau of the amount of data available. But even that doesn't take into account that GPT-4 wasn't trained on video data, so that's a whole lot of new data that's coming. So I just haven't heard much of a reason why you believe what you believe. Now, if I had to give some odds that GPT-5 was going to be a huge breakthrough compared to an incremental step, I guess I see why it's tempting to lean towards saying it's going to be an incremental step. In my case, the evidence that makes me believe that is just trend extrapolation from looking at other companies' models, like Elon Musk's X.AI Grok model that just came out is kind of comparable to GPT-4. And the Llama models from Meta are almost approaching GPT-4, and the Claude model is like slightly better than GPT-4 in a lot of benchmarks, but not significantly different. So extrapolating that kind of trend does hint that maybe there's a plateau, and so that's why I might believe what I believe weakly. But I don't believe that strongly. I don't have a strong skepticism because GPT-5 is going to be a new advance by a lab that's ahead of the other labs, right? They got an earlier start. So if Arvind is basing his prediction off anything other than just empirically observing what's coming out from other companies, then I'd like a better explanation of what that is.
Can we just take them one by one there? There was a lot of great things that I just want to unpack. You said there about kind of, potentially the shortage of data being the bottleneck to performance. A lot of people say, well, there's a lot of data that we haven't mined yet, which the obvious example that many suggest is kind of YouTube, which has obviously, I think, 150 billion hours of video. And then secondarily to that, synthetic data, the creation of artificial data that isn't in existence yet. To what extent are those effective pushbacks?
Whoa, Harry Stebbings coming in with a perfect challenge. I didn't know Harry was about to ask that. I'm just going through the podcast linearly. So great question, Harry. What happens when we dump in all this other data from YouTube as well as synthetic data? Doesn't that indicate that we might get another leap in intelligence?
So there are a lot of sources that haven't been mined yet. But when we start to look at the volume of that data, how many tokens is that? I think the picture is a little bit different. 150 billion hours of video sounds, really impressive. But when you put that video through a speech recognizer and actually extract the text tokens out of it and deduplicate it and so forth, it's actually not that much. It's an order of magnitude smaller than what some of the largest models today have already been trained with. Now, training on video itself instead of text extracted from the video, I think that could be That could lead to some new capabilities, but not in the same fundamental way that we've had before, where you have the emergence of new capabilities, right? Models being able to do things that people just weren't anticipating. So like the kind of shock that the AI community had when I think back in the day, I think it was GPT-2, was trained primarily on English text, and they had actually tried to filter out text in other languages to keep it clean, but a tiny amount of text from other languages had gotten into it. And it turned out that that was enough for the model to pick up a reasonable level of competence for conversing in various other languages. So these are the kinds of emergent capabilities that really spooked people, that has led to both a lot of hype and a lot of fears about what bigger and bigger models are going to be able to do. But I think that has pretty much run out because we're training on capabilities that humans have expressed, like translating between languages, and have already put out there in the form of text. So if you make the data set, a little bit more diverse with YouTube video, I don't think that's fundamentally going to change. Multimodal capabilities, yes, there's a lot of room there. But new emergent text capabilities, I'm not sure.
Arvind makes a good point that when you ingest YouTube videos, if most of the value is just the words spoken in the video, then it doesn't augment the corpus of the internet that much. But he also acknowledges, hey, maybe there's data in what's in the video, and that'll actually be much more data than before. So he acknowledges he might be wrong. My personal guess is that it's not going to move the needle a ton to have this new data set of videos because, like I said before, the internet is already pretty predictable once you've seen half the internet. So even YouTube gets pretty predictable once you've seen half the internet. So I just don't see any other data corpus making that big of a difference. That's just my personal guess. What's salient to me is that the jump from GPT-3 to GPT-4, the number of tokens in its dataset only went up by about a factor of 2. GPT-3 had about 300 billion tokens in its dataset, and then that doubled to maybe 600 billion in the dataset for GPT-4. My gut says that when we see the progress from GPT-3 to GPT-4, it's probably because the model has more parameters and maybe other architectural tweaks. It's probably not so much because it has twice as many tokens of data, but I might be wrong. I'm just guessing based on intuition. If my guess is wrong and it really is just twice as good because they doubled the tokens, well, then there's definitely potential for them to double the tokens again. So Arvind is out here claiming GPT-5 is not going to have the same delta as from GPT-3 to GPT-4. He's putting a lot of weight in the size of the dataset and acting like that's predictive, when I just don't see much reason to believe that it's very predictive at all. I think you might just get a surprise that GPT-5 is smarter than GPT-4, even when it doesn't have that many more tokens. Now, to be fair, he is hedging a lot. He's not acting really confident. My only beef is I'd like to see him come out and say, look, I have no idea. I'm prepared for anything. I don't want to place any bets, and I don't want to act like I've said anything which is a falsifiable prediction. I'm just as uncertain as somebody with no background in the field. The only reason I'm on his case is because when you listen to him talk, he sounds like his statements contain predictive information. He sounds like he's saying things that should help you constrain your anticipation. But I think he's actually hedging his way out of constraining your anticipation at all. So I'd like to see him use language that's more upfront and explicit about his epistemic humility, about his almost maximum uncertainty knowledge state, rather than using language like, I'm skeptical that GPT-5 can do that, when I think he's actually not as skeptical as he's coming off. I think he's actually hedging his bets more than his words would imply.
What about synthetic data? What about the creation of new data that doesn't exist yet?
Boom, another good question from Harry.
So there's two ways to look at this, right? So one is the way in which synthetic data is being used today, which is not to increase the volume of training data, but it's actually to overcome limitations in the quality of the training data that we do have. So for instance, if in a particular language there's too little data, you can try to augment that, or you can try to let's say, have a model, solve a bunch of mathematical equations, throw that into the training data. And so for the next training run, that's going to be part of the pre-training. And so the model will get better at doing that.
I'm not sure I understand Arvind's distinction between increasing the volume of training data versus overcoming limitations in the training data set. Isn't it a limitation when you don't have enough volume of data? He used the example of synthetically feeding it translated data and synthetically feeding it solved mathematical equations. It seems like what those examples have in common is that they're relatively short derivations of one type of data from another type of data. But if that's what he means, why doesn't he talk about it in those terms? I don't feel like he is being very clear about what the problem is with generating a bunch of synthetic data in order to potentially have 10 times more tokens feeding into GPT-5 than we had for GPT-4. What's the fundamental problem? He's being vague.
And the other way to look at synthetic data is, okay, you take 1 trillion tokens, you train a model on it, and then you output 10 trillion tokens, so you get to the next bigger model. And then you use that to output 100 trillion tokens. I'll bet that's just not going to happen. That's just the snake eating its own tail.
What you're calling snake eating its own tail, or you might call it like a free lunch, something that intuitively seems impossible, it's not impossible in every case. I mean, if you look at the GPT-3 and GPT-4 models that we have, this is a surprising fact to me, but the amount of information contained in the GPT-3 and GPT-4 models themselves is actually like 5 times larger than the amount of information in their data set. Because intuitively, you think of intelligence as being able to compress data. I mean, that is by definition the heart of understanding. The heart of science is that I can write down a description of the universe which is compact, and yet it lets you constrain your anticipation in a lot of different scenarios across a vast region of space and time, across a wide range of applications. Each of us carries in our head 3 pounds of meat that we use to navigate a universe that weighs a lot more than 3 pounds. So that's why I came into this thinking, surely these models are smaller than their data sets, but they're actually larger. Why is that? Well, I'm not sure because they're black boxes, but I think a good guess is that they're just slicing and dicing the information that they learn in a lot of deep ways. They're making it easier to search using caching and denormalization, but of course not naively using keywords, but more robustly using deep concepts, using embeddings. But that's the general idea, I think. And the human brain does the same thing too. We know it has to do it because it operates so slowly in serial time. The human brain can only do about 20 serial computation steps per second. So the only way the human brain gets anything done is by having a really large cache so that it can accomplish most of the cognitive work it needs to do just by looking something up in this vast cache. So that's why you get a situation where these models can be crazy huge because of all this, let's call it denormalization that they're doing, all this redundantly copying data, where yes, it's data that we know for a fact is an inferential consequence of other data, because we know they only got trained on like 300 billion tokens. So why would the model need to be more than 300 billion tokens worth of size? But it is bigger. We can say that models are denormalized in the sense that it's a big chunk of state information, which is deductively, logically determined by a smaller chunk of information. We know that about these models. So now let's get back to the scenario of I use an LLM to synthesize more tokens than I got trained on, and I train the next LLM on that. Why couldn't that be the same kind of denormalization process that makes GPT-3 and GPT-4 smart in the first place? You might say from an information theoretic perspective, you're not adding any information by doing this kind of denormalization, or you're adding very little information because it's so compressible. But look at what we call organic data. The internet is already highly compressible, right? You can gzip the internet, and of course LLMs are better compression algorithms than gzip. So when an LLM is scanning over the internet, a lot of it is just yada, yada, yada predictable. So if we feed another organic grass-fed web page into GPT-5, that's not necessarily going to add more information than if we feed a deductively generated piece of content from GPT-4. That's one counterargument I have to Arvind casually saying it's the snake eating its own tail. The other counterargument I have is you can use other AIs to synthesize the data, or you can use a Unity 3D physics simulation to synthesize the data, or you can use Mathematica. There's all these artificial sources of data that, as far as we know, could be extremely useful, could potentially be more useful than going and pulling down some other web page on Facebook from a human. So to me, this just continues to fit into the pattern of Arvind making these vague statements that don't give us any predictive power, but still sound like there might be some kind of substance to it if you talk to him more.
What we've learned in the last 2 years is that the quality of data matters a lot more than the quantity of data. So if you're using synthetic data to try to augment the quantity, I think it's just coming at the expense of quality. You're not learning new things from the data. You're only learning things that are already there.
So here he's saying synthetic data is lower quality than organic data, and you can never match the quality of organic data using synthetic data. But why is that? If you're trying to show somebody examples of stuff happening in the physical world, why can't you use a state-of-the-art physics engine to produce a lot of data showing that? Isn't that quality data, not just quantity data? Is there really a line dividing quantity data versus quality data? Let's say we want GPT-5 to be better at undergraduate physics. What if we make it go through all the physics textbooks and keep generating new questions and then answering them and checking its work, and just do it over and over again until you've generated many gigabytes of data of this kind of exercise? Is that purely quantity data? Because it's never been seen before. You can argue, yeah, but it's denormalized. It contains no new information. It's merely crunching through the logical consequences of things that are already present in the AI's other data. Okay, but wait a minute. Once you start crunching through logical consequences, that's something that the AI can't do rapidly at inference time. It's very limited by the process of inference, right? You can't just jump your inference all the way to solving a problem if the problem solving actually takes a lot of inferential steps. So the exercise of doing these inferences and then feeding in the output into your cache, into your giant denormalized model, that could potentially be useful. Why are you calling that quantity instead of quality? How do you know, Arvind? What do you think you know, and how do you think you know it? That's what I'm not getting here. I also just want to note that while Harry Stebbings did a great job asking Arvind about pulling in new data from YouTube and generating synthetic data, he didn't challenge Arvind with my other objection, which is, what if compute actually is the bottleneck and we just need to break through the next compute barrier, and we're going to have another big grokking, and we're going to have another big breakthrough in all of our benchmarks, and we're going to close a lot of the gap toward superintelligence? What about that scenario, Arvind? I don't think Harry ever asked that, but let's move on.
One thing that, while we're on kind of utility value of data, when we look at effectiveness of agents, I've had Alex Wang at Scale.ai on the show, and he said the hardest thing about building effective agents is most of the work that one does in an organization, you don't actually codify down in data. You remember when you were at school and it says show your thinking or show your work. You don't do that in an organization. You draw on the whiteboard, you map it out, and then you put down what you think in the document. The whiteboard is often not correlated in a data source. To what extent do we have the data of showing your work for models, agents to actually do in a modern enterprise?
Yeah, I think that's really spot on. I think one way in which people's intuitions have been kind of misguided by the rapid improvements in LLMs is that all of this has been, in the paradigm of learning from data on the web that's already there. And once that runs out, you have to switch to new kinds of learning. It's the analog of, riding a bike. That's just kind of tacit knowledge. It's not something that's been written down. So a lot of what happens in organizations is the cognitive equivalent of, I think, what happens in the physical skill of riding a bike. And I think for models to learn a lot of these diverse kinds of tasks that they're not going to pick up from the web, you have to have the cycle of actually using the AI system in your organization and for it to learn from that back and forth experience instead of just passively ingesting.
Tacit knowledge in an organization is like a process that isn't written down somewhere, but the organization can consistently perform it because different people are in the habit of performing fragments of it. So it's implicit knowledge, and it can be made explicit if somebody looks around and documents the process. It's not theoretically impossible to write down. It's a fair point that a lot of large organizations haven't documented all of their important processes. But if you're asking the question, why don't we have agents? I think this point by Arvind, and to be fair, I guess it's copying a point by Alexander Wang, that point seems to only be secondary to the more primary point that the AIs just aren't robust yet. If you have a framework like AutoGPT, which basically just runs GPT in a loop, saying, what should I do next? What should I do next? Pretty quickly you go off the rails because it doesn't quite give you good answers for something that it can do next. It's just not robust. Even if you enter, let's say, a remote-first organization where they thoroughly document every process, and a human being could read it and get onboarded because there's enough explicit knowledge, even in a scenario where there is no latent knowledge. In AutoGPT, an attempt at doing an agent using GPT-4 would quickly derail anyway. So I think Alexander Wang and Arvind are really getting ahead of themselves to even talk about latent knowledge. Sure, that's a problem, but that's already a problem for managing humans. That doesn't explain why you can't just hire an AI today and just instantly wipe out six-figure human after six-figure human. There's something else more fundamental going on, which I think in a word is robustness.
To what extent do you think enterprises today are willing to let passive AI products into their enterprises? to observe, to learn, to test? And is there really that willingness, do you think?
I think it's got to be more than passive observation. You have to actually deploy AI to be able to get to certain types of learning, and I think that's going to be very slow. And I think a good analogy is self-driving cars, of which we had prototypes, 2 or 3 decades ago. But for these things to actually be deployed, you have to roll it out on slightly larger and larger scales while you collect data, while you make sure you get to the next 9 of reliability, 4 nines of reliability to 5 nines of reliability. So it's that very slow rollout process. It's a very slow feedback loop. And I think that's going to happen with a lot of AI deployment in organizations as well.
It certainly can't hurt to deploy an AI in order to get data for it, to see where the disengagements are, by analogy with driving your Tesla, right? If you don't like what the self-driving is doing, you disengage it. So if you have an AI worker who's substituting for like a human remote worker, and you see how often you have to disengage it and say, no, that's wrong, stop, let me fix you, that's certainly one good way to get a feedback loop going and to get AI employees. But I don't think it's essential. Even in the case of self-driving cars, if you start a new self-driving car program from scratch, and all you give it is video footage from cameras of regular humans driving cars, so you don't create a feedback loop. There was never a time when you deployed an AI in a car and you saw when it messed up or you saw when it disengaged. It's just entirely passively observing humans driving cars. Now, of course, you have feedback in the sense of sometimes the human successfully completes their trip, sometimes they slam on the brakes, sometimes they crash. So there are positive and negative reinforcement loops in that sense, but you never have to deploy the AI. I suspect we're a few years away from getting to the point where an AI can just vacuum up all that instructive data without ever being deployed and come out with a conclusion of like, okay, this is how you drive. This is what the human driver would do to correctly navigate every obstacle. So I wouldn't make the claim too strongly that a feedback loop involving the AI itself is essential. That's not how AI has to work. Or consider if we make an analogy to AlphaGo, it does a lot of self-play, but that's also different from being deployed. That's like, imagine that you're deployed. What would you do in that situation? How do you think it would work out? Try simulating it. Try feeding yourself the consequences of that and then adjusting on the fly. So that's another scenario, this kind of self-play scenario where you self-play a billion games of remote work job. In that scenario, once again, you're also not deployed and getting a real-world feedback loop. So I'm not saying there's anything wrong with deploying an AI. It just seems to me arbitrary that, once again, Arvind is acting like he has a piece of knowledge or acting like he has some sort of anticipation constraint to share with us, but he's just kind of picking part of the probability distribution and arbitrarily focusing on it. Like, I don't know why he didn't, for the sake of comprehensiveness, also point out that you can have AIs that do self-play, and you can have other AIs that do a deep analysis of a rich corpus of human data. Why not point that out? It just seems like he's leaving out important context about how else things could play out, context about how else we could suddenly get these super intelligent AIs that are easy drop-in replacements for human employees. He's leaving out other major ways that this could happen when he just focuses on a feedback loop that you get when you actually put the AI into the organization, so you can let the AI really be part of the organization and be very empirical and get its feedback that way. That's only one possible path, so let's broaden the context here. In this next part, Arvind repeats a very popular type of argument that I feel like misses an important point. Let's check it out.
There's the saying that every exponential is a sigmoid in disguise. So a sigmoid curve is one that looks like an exponential at the beginning. So imagine the S letter shape, but then after a while it has to taper off, like every exponential has to taper off. So I think that's going to happen both with models as well as with these hardware cycles. I can't predict how long that's going to take, but we are, I think, going to get to a world where models do get commoditized.
Okay, so the implication that you haven't acknowledged here is that they might only taper off after becoming extremely intelligent. If you don't think that's the case, if you don't think they're going to taper off when they reach thousands of IQ points, let's say, as some of us think, if you don't think that's the case, don't you want to explicitly mention it and rule it out instead of just making a logical non sequitur where you say, yeah, every exponential has to taper off, so I think we're going to get a situation where these are just commodities that you can go buy at Costco and everybody can just have one in their house and everything is just chill. The final taper off period, you said yourself, you don't know when it is. So let's talk about whether it's going to be after superintelligence. That's the critical point here. Again, just the fact that you're feeding Harry Stebbings this line of like, the exponential is going to turn into a sigmoid curve, so eventually it's going to be a commodity and he just buys it and moves on. Wait a minute. This is a key point. This is a key point where the transformer scaling is going. How can you not at least acknowledge, like, I would be totally fine if Arvind communicated himself like this. Hey guys, currently AI is growing as an exponential. I think it's going to taper off. Now, you may be worried that it's going to taper off at a very scary, super intelligent place, but don't worry, because my position is that it's going to taper off at a very harmless place that's actually subjectively not much different from GPT-4. I just want to tell you that that's my position, contrary to the position of a lot of other important figures who are sounding the alarm that it's going to taper off at a much, much higher place. That is my position. If Arvind communicated clearly like that, I would feel like that is a good way to place his viewpoint in its proper context. So I continue to be alarmed. This is kind of the impetus for me doing Doom debates, right? Is that I listen to these other podcasts. I hate listening to them, just like I know a lot of you guys do. And people keep saying stuff in a very don't look up type of fashion. It has a missing mood, right? The vibe of like, hey, a lot of people are saying there's that asteroid coming there on a trajectory toward Earth. How about you acknowledge that some telescopes are pointing there? You know, maybe you don't see it. Maybe you have calculations that differ, but how about acknowledge what some people are telling you is the topic of discussion? Or else it's like you're just willfully trying to stay in your bubble of acting like everything is just tech. It's just the latest gadget. It's just going to be normal because every exponential has to eventually end. Next, I just want to flag this random comment Arvind makes that seems out of touch with the practical reality of things.
When GPT-4 came out and OpenAI claimed that it passed the bar exam and the medical licensing exam, people were very excited / scared about what this means for doctors and lawyers. And the answer turned out to be approximately nothing, right? Because it's not like a lawyer's job is to answer bar exam questions all day. These benchmarks that models are being tested on don't really capture what we would use them for in the real world.
Arvind does have a point here that benchmarks aren't perfect. So if you use the bar exam or a medical licensing exam as a benchmark and the AI passes it, that doesn't tell you everything you need to know about whether you can hire the AI as a doctor or a lawyer. Sure, okay. But it seems like he's gone way too far in his explanation here and downplayed how big of a breakthrough it is that AIs are actually really good at medicine and law right now. Like when he says, this means approximately nothing for doctors and lawyers. How many times have all of us avoided a consultation with a doctor or a lawyer because we could type something into our LLM? I know I have, and I know other people have too. So I just don't get why he's saying absolutely nothing changed. Like things are changing. There's plenty of startups now that are making software to gradually chip away at doctors and lawyers in ways that they couldn't before. And in certain industries like customer service, we're seeing wholesale replacement, right? Chipping the team away down from like 1,000 to 50, like actual stories of companies firing actual people, right? Customer service, sales, writers, designers, those are kind of the tip of the iceberg, I guess. Those are the first to fall. And yeah, you can point to doctors and lawyers and they have strings that are still holding them in place. Maybe a judge doesn't want to talk to an LLM. Maybe you have to have a warm body appear in court. Or there's a bunch of connective tissue of the job that hasn't been measured by the benchmark. Sure, okay, fine. But just like, there is an oncoming wave here, right? So I don't know how to file away this comment by Arvind that nothing has changed for doctors and lawyers. Maybe it was just like a throwaway comment to make his point. It just seems like a consistent pattern where he's trying to act like everything is normal and we should just expect AI to like keep being normal. But I guess I would just encourage him to entertain the possibility that maybe things are starting to get very freaky and not normal.
I do just want to kind of move a layer deeper to the companies building the products and the leaders leading those companies. You've got Zuck and Demis who are saying that AGI is further out than we think. And then you have Sam Altman and you have Dario and Elon in some cases saying it's sooner than we think. What are your reflections and analysis on company leader predictions on AGI?
So let's talk for a second about what AGI is. The definition that we consider most relevant is AI that is capable of automating most economically valuable tasks. So it's a very pragmatic definition. It doesn't care about, whether it's conscious, does it think like a person? Those questions are, frankly, not that interesting to us, but also harder to predict or reason about.
I think that's a totally serviceable definition if you want to use that definition. Of course, I always go to the definition of human level at optimizing over a broad domain. So I can give you a problem of the form, get the universe into an end state satisfying this criterion, and the AI can do it better than a human can. But in layman's terms, saying that it can automate any economic role that humans have, that's roughly the same idea.
So by this definition, of automating most economically valuable tasks, if we did have AGI, that would truly be a profound thing in our society.
Yeah, and the major doomer prediction is that once you get to that point, maybe a little bit above it, hopefully above it, but at some point you get into a cascade, you get into a positive feedback loop, because among the things you're now automating is further intelligence enhancement. So the moment we can get AIs to IQ 200, it might not be long before they're up at 250, 300, 500, 3000. That's the positive feedback loop that we're worried exists, especially when we look at the evidence of wow, the human brain sure started getting much bigger before it was limited by the size of the birth canal. That strongly indicates that it's not necessarily that hard to tweak the architecture of a human brain to just make it a little bit bigger and squeeze potentially a lot of new IQ points out of it that we've never witnessed before on Earth. So there are some signs, there are some reasons to expect that higher IQ is a low-hanging fruit that might be picked pretty soon once we hit this kind of AGI threshold, at or around that threshold, hopefully a little bit higher than that threshold. But anyway, let's hear what Arvind has to say about AGI.
I think one thing that's helpful to keep in mind is that there have been these predictions of imminent AGI since the earliest days of AI for more than a half century. Alan Turing, when the first computers were built or about to be built, people thought, the two main things we need for AI are hardware and software. We've done the hard part, the hardware, and now there's just one thing left, the easy part, the software. But of course, now we know how hard that is. So I think historically what we've seen is it's kind of like climbing a mountain.
I think Alan Turing was pretty much on point when he said that hardware was a hard part and now we just have to nail the software. It was an absolutely brilliant observation for Alan Turing to have the perspective to realize that him just sitting in a room with an old-fashioned computer that just had a million wires and knobs and vacuum tubes, to look at that and to be like, oh my God, our civilization is now most of the way there towards superintelligence, even though it didn't subjectively feel like it, right? It was just like spitting out a few numbers here and there. But to correctly realize that it would only take another century or maybe 2 centuries. I think there's very few people today who will tell you yeah, it's not going to take till 2036. It's going to take till 2136. I think we're really pushing the limit here. But let's be very generous and say, okay, Alan Turing was 2 centuries before we have superintelligence. Okay, but he was looking backwards all the way back to the 1800s and Charles Babbage with his difference engine, and before that to the ancient Greeks with formal logic. He was looking at all this perspective and he's like, you know what? I think we're getting close to the end. I think the hard part is behind us. So I think Alan Turing was correct and we should appreciate his perspective. Now, if Alan Turing was saying, hey, the software is only going to take 5 years. Okay, hypothetically, if he had said that, and maybe some people did say that, right? Like the famous graduate project, the graduate student who was assigned to go solve computer vision over a summer break, right? Yeah, in some cases, people underestimate how long the software is going to take. Okay, but I think extending that argument to say that it's going to take more than another few decades from where we are now, I think that that's going way too far, right? Which is why prediction markets are saying, okay, we've kind of narrowed it down most likely to be within a couple years to a couple decades, maybe a few decades, probably less than a century, right? A century would be pretty crazy. Why is it taking another century when we're practicing the freaking Turing test and we're having a hard time even saying what it can't do?
Wherever you are, it looks like there's just kind of one step to go. But when you climb up a little bit further, the complexity reveals itself. And so we've seen that over and over and over again. Now it's we just need to make these bigger and bigger models. So you have some silly projections based on that. But soon the limitations of that start becoming apparent. And now the next layer of complexity reveals itself. So that's my view. I wouldn't put too much stock into these overconfident predictions from CEOs.
This is similar to the kind of stuff that Robin Hanson says. It's pretty popular to make this argument that Arvind's making of everything is relative. It always feels like we're on the brink of superintelligent AI, but it's actually always a long, long time away. And then you realize that this thing that you think is easy, just get the software right, just get vision right. It turns out that that's going to take you many decades, and then you're still going to have many decades, and you're going to forever have many decades, or, who knows? Okay, hold on a second. There is an objective way you can get frames of reference here. For example, if we just go back 10 or 20 years, and at the time, if you looked at the kind of lists that people made of things AI can't do yet, AI cannot yet recognize whether an image has a cat or a dog. AI cannot yet have a natural conversation with you, right? Not even close to passing the Turing test. AI cannot translate languages as well as a human can. AI cannot pass a high school or college level economics exam. AI cannot pass the bar exam, pass a medical exam, not even close. AI cannot generate video. AI cannot drive a car 10 times safer than a human in San Francisco, right? Talking about Waymo. These are all lists of things that we would have had these ideas. It's not like I have to be in the year 2024 to even tell you that these are interesting challenges for an AI. No, I could have sat here in the year 2004 and written down all of those different tasks for AI, and I would have told you it can't do this, it can't do this, it can't do this. Fast forward 20 years, now it's doing all those things. Can it literally drop in, replace you for different jobs? No, only some, right? Only a lot of customer service jobs, right? Only a lot of copy editor jobs, only some jobs, not all jobs. But this is what I'm saying. The list of things that we've written in advance, so objectively, not just we're writing on the spot, or things that we could have written 20 years ago, the list of things is undeniably getting shorter. And it's hard to add extra bullets to the list. It's hard to draw an analogy to be like, okay, yeah, today I could write you 5 bullets about like latent knowledge that an employee in an organization needs. That's just not going to be analogous to being like, hey, can you get behind the wheel of a car in the entire city of San Francisco and take a passenger safely? It's just not going to mount. Like a lot of the challenges really are behind us. And that's where the speculation comes from. That's why the prediction markets, the best estimate of these predictors is that AGI is coming in not more than a couple decades, maybe 3 decades. So this very relativistic argument of like, oh, we can't tell where we are on the progression toward AI, I think that's too humble. That's denying an objective frame of reference that we can look at.
Is it possible to have a dual strategy of chasing AGI and superintelligence, as OpenAI very clearly are, and creating valuable products at the same time that can be used in everyday use? Or is that balance actually mutually exclusive?
It would take a discipline from management to be able to pull it off in a way that one part of the company doesn't distract another too much. And we've seen this happen with OpenAI, which is the folks focused on superintelligence didn't feel very welcome at the company, and there has been an exodus of very prominent people, and Anthropic has picked up a lot of them. So it seems like we're seeing a split emerging where OpenAI is more focused on products and Anthropic is more focused on superintelligence.
Wait, what? I just included this part in here because it's an interesting alternate history of why a bunch of people have leaked out of OpenAI and headed over to Anthropic. It's pretty clearly because they're concerned about safe superintelligence. They're worried that OpenAI is being irresponsible in their approach toward superintelligence, not because OpenAI just wants to build products for today and not care about superintelligence. No, I think OpenAI's leadership, particularly Sam Altman, really wants to build superintelligence. I think that's why he started OpenAI. It's because he wants the ultimate power and giant universe scale rewards that, to be fair, can potentially, there is a upside scenario if you somehow overcome the safety problem, right? I mean, that's the big prize that's clearly always motivated Sam Altman, even if you just listen to what he says without trying to psychoanalyze him. It's just funny to me that Arvind is like, yeah, OpenAI doesn't prioritize superintelligence. I mean, surely they have to make money today. There's no doubt about that. But you can't characterize the difference between them and Anthropic by saying only Anthropic wants to build superintelligence. You would characterize the difference correctly by saying that Anthropic takes the safety risk and the existential risk much, much more seriously and is less confident about their ability to overcome the risk, is more properly humble about it. But I should also add a note that I'm not a fan of either lab. I think the actual problem of making AI safe is much more intractable than Anthropic people allow themselves to think on a daily basis. They see themselves as these careful missionaries who are going to make sure that we get to super intelligent AI in a responsible way, when in reality, they're in way over their head and they're actually part of the problem. I do like them on a personal level, and I like that they're kind of the good AI lab, but they're just the best of the worst, and they're still accelerating the arms race. And they're very much responsible for screwing over humanity from my perspective, almost as much as any of the other labs. That's just my 2 cents, and I'll probably keep talking more on this theme in different episodes, which is the problem of AI safety is intractable on a 10-year timeline. You have to have that perspective that you're staring down an intractable problem. Some research problems take more than 10 years to solve, like many of the ones in theoretical computer science, like many of the Millennium Prize problems. They take more than 10 years to solve. And we're all just conveniently acting like we have to solve AI safety in 10 years, So we're going to dedicate like 100 minds to it, and then we're going to also build capabilities. It's insane, but I digress.
We've been in this kind of historically interesting period where a lot of progress has come from building bigger and bigger models. That need not continue in the future. It might, or what might happen is that the models themselves get commoditized, and a lot of the interesting development happens in a layer above the models. We're starting to see a lot of that happen now with AI agents. And my hope is that we will transition to that kind of mode of progress in AI development relatively soon.
Oh, that's my hope too. Wait, why is that your hope? It's my hope because it implies that we must be hitting an AI winter if all we can do is build applications on top of existing LLMs. That would be fantastic. I would love to just focus on building applications on top of existing LLMs. I would love to have an international treaty saying, don't worry about what would happen if you built a bigger model. You don't have a choice. Just go build applications on the current model. That would be my dream scenario because it would buy us a few years or even decades in an ideal world to understand intelligent science, understand principles of how we could even in principle make an AI that was aligned and or controllable. That would be nice to have a little bit more time. So if that's why Arvind is saying, let's focus on applications because models are going to stall out and be a commodity, then great. But he didn't spell that out. So I find it weird that he's just talking about how he hopes that the exponential flattens out into an S-curve so soon, instead of continuing longer and longer as an exponential and creating way, way more value until, of course, it goes too far and also becomes unaligned and uncontrollable. I just don't know what his mental model is when you draw outside the lines of the last couple of years. I don't understand what his extrapolation is. He seems to be imagining a world where things are all pretty normal. I don't want to put words in his mouth, but it just seems like when I listen to him talk, I'm always thinking about a scenario that feels normal. And I would never psychoanalyze somebody. I would never say, this person always suggests ideas that maintain their sense of normalcy. It's not my place to psychoanalyze that that's how his thinking works. I'm just observing that everything he's saying seems to keep my sense of normalcy in place as I listen to it. And that's not how I think the future will evolve.
When I had Ethan Mollick on from Wharton, he was like, the best thing to do actually is like allow and watch a policy. He said essentially we should let everything flourish and then regulate from there rather than proactively regulate ahead of time, not knowing outcomes. Does that ring true to you?
I broadly agree with that. My worry is that if we treat this as a technology problem and try to intervene on the technology, we're going to miss what the real issues are and the hard things that we need to be doing to tackle those issues.
This is a popular topic of discussion. It also comes up a lot with the recent discussion around California's SB 1047 bill, which seeks to be kind of proactive in how it regulates AI. It wants the frontier model builder to submit in advance a safety plan that's predicting why their AI model is going to be safe and how we're going to mitigate harms. And people are objecting understandably. They're saying, why can't we just regulate the applications? This is just a model that's going to empower different actors to do different things. Why not come down hard on the actors? Why blame the model builders when we could blame the actors? Like if somebody uses Photoshop or Microsoft Paint to go draw something naughty, do we really want to blame Photoshop and Microsoft Paint? No, of course not, right? Maybe it should be really hard to make your AI produce a deep fake. Maybe that shouldn't be like one of the buttons in the toolbar. There's a valid point there. But if the technology is out there to make deep fakes, I don't necessarily think we have to restrict that more than we restrict other tools like using Photoshop to draw something naughty or using Microsoft Word to write a very bad kind of note, right? I'm very sympathetic to the view of like, look, tools are tools, and a lot of times the blame does rest on the actors. The reason why we're talking so much about proactive regulation like SB 1047 is because of the possibility that it's going to be a mass scale weapon, like it's going to be a generator of computer viruses where a single prompt can output a downloadable, executable virus where, it'll bill itself as, oh, this is a helpful script. This will help you run your business. But it's essentially a virus, and it does a lot of damage, and it has effects that can't easily be rolled back. That's why the bill is literally talking about $500 million plus of damage being the threshold where the Attorney General is allowed to give you an additional fine in addition to injunctive relief. These are huge thresholds. The point of the bill is because we're anticipating that there might be a runaway scenario, a mass effect scenario that takes us into the regime of more like regulating a weapon of mass destruction. If we all agree that we're for sure going to stay in the regime of regulating consumer products, then yeah, it's not a big deal. I wouldn't even support SB 1047 if I thought we were for sure going to stay in the regime of regulating consumer products. That's the crux of disagreement between a lot of us SB 1047 supporters and the opponents. A lot of the crux of disagreement is just, do you even think that it's possible that AI is going to go super intelligent and that's going to pose a huge danger? And we're going to really need to do everything we can to prevent that from happening. If you are worried about that, as I am, then you can see the need why SB 1047 is kind of the least we can do. If you're not worried about that at all, then yeah, of course, you should just be like, you should release the model. We should just blame the person building the application. The issue is that if you let anybody go and roll their own weapon of mass destruction, and one person pulls the trigger and fires it for whatever reason, yeah, you can go blame that person, but the problem is you just created mass destruction, right? That's the problem. So even the person who kicked off the mass destruction might even be dead. It's not really a problem of let's punish that person. It's a problem of like, how do we avoid mass destruction? That's why I'm never interested to say, let's regulate the AI application layer. Yes, that's true by default. You don't even need to pass new laws to just regulate the application layer. You can use existing laws to achieve that. If you want to pass new laws about the application layer, fine. But what's much more important is to get right regulations on any potential paths to superintelligence, which I would go all the way down the slippery slope and say we're already close enough to superintelligence that we need to pause now. Hence, pauseai.info. Check it out. It's an organization I'm part of.
You know, we had Alex Wang from Scale on, I mentioned earlier. He said that AI has the potential to be a bigger weapon than nuclear weapons. How do you think about that? And if that is the case, should we really have open models?
I think, it's a good question to ask. I think it's a bit of a category error there. I mean, a nuclear weapon is an actual weapon. AI is not a weapon. AI is something that, might enable adversaries to do certain things more effectively to, for example, find vulnerabilities, cybersecurity vulnerabilities in critical infrastructure, right? So that's one way in which AI could be used on the quote unquote battlefield.
Imagine I asked ChatGPT, write me a virus that will take down all the systems in the Pentagon. And then I press enter and it outputs a script and I run the script and then it runs and it copies itself on different computers and it starts stealing resources on the internet and hopping across nodes and finding zero-day vulnerabilities and eventually getting into the Pentagon systems and disabling them. Sure, it's a little fanciful. You're going to need GPT 6 or 7 maybe to pull it off. You can't do it in GPT 4. But is it a category error? Is it logically incoherent to talk about a cyber weapon? No, right? And that's before it even commandeers human brains and manipulates people and bribes people or builds nanotechnology. That's even before we get into all that good stuff. When we're just saying, hey, press enter to take down the Pentagon, is that not a weapon? Can you not take down other critical infrastructure that has the effect of killing people? Is that not a weapon? Category error is such a harsh criticism to levy against a claim. To say it's a category error, it's basically saying that the person making the claim is so confused. It's basically saying that they just aren't even being coherent in what they're suggesting. So it's actually incredibly harsh that Arvind is telling Harry, he's like, you know what, Harry, you just asked me a question that you must be so confused to be asking me how AI can be a powerful weapon. AI being a weapon? What? That's crazy. The whole idea is incoherent. No, but it's not an incoherent idea. The fact that you can go on a public podcast and accuse AI as a weapon of being a category error, it's just so low quality of an accusation that I'm surprised that it's kind of in his brain as a cached accusation to bust out at a time like this. It's really, really low quality as a response to Harry's question. I never want to respond to somebody telling me that it's a category error when I bring up the subject of whether AI is a big threat. It's clearly a coherent question on my part and on Harry's part and on Alexander Wang's part to ask whether AI can be a powerful weapon. Okay, I got that out of my system.
I think it would be a big mistake to view it analogously to a weapon and to argue that it should be closed up for a couple of reasons. First of all, it's not going to work at all. So I think we have, close to state-of-the-art AI models that can already run on people's personal devices, and I think that trend is only going to accelerate. We talked earlier about Moore's Law, and it still continues to apply to these models. And even if one country decides that models should be closed, the odds of getting every country to enact that kind of rule are, just vanishingly small. So if our approach to safety with AI is going to be premised on ensuring that quote unquote bad guys don't get access to it, we've already lost, because it's only a matter of time before it becomes impossible to do that.
So what I'm hearing is, it would be a big mistake to view AI as potentially analogous to a weapon of mass destruction. Because if it were analogous to a weapon of mass destruction, then it would be really important to regulate it so that we don't just hand out weapons of mass destruction to everybody. By not viewing AI as being analogous to a weapon, we thus don't have to deal with the implications that there's going to be a big old weapon that we have to deal with. It's no longer going to be a problem because we don't view it as a weapon. Problem solved.
Instead, I think we should radically embrace the opposite, which is to figure out how we're going to use AI for safety in a world where AI is very widely available, because it is going to be widely available. And when we look at how we've done that in the past, it's actually a very reassuring story. When we go back to the cybersecurity example, for 10 or 20 years, the software development community has been using automated tools, some of which you could call AI, to improve cybersecurity, because software developers can use them to find bugs and fix bugs in software before they put them out there, before hackers even have a chance to take a crack at them. My hope is that the same thing is going to happen with AI. We're going to be able to acknowledge the fact that it's going to be widely available and to shape its use for defense more than offense.
I just want to point out that Arvind kind of cycled through 3 positions in the short span of his answer. First, he was like, AI being a weapon, that's a category error, which is just obviously factually false. So he kind of moved past that pretty quick. Next, he said, there's no point in treating AI like a weapon, because how would you ever hope to regulate a weapon that's already in everybody's hands? And then finally, he came around to, we got to make sure to keep AI's defensive capabilities ahead of AI's offensive capabilities. That's kind of his final resting place. And sure, that would be nice, but I think that it's even more prudent to not count on the fact that we should expect to be able to do that, and to be even more prudent than that. Because what I'm expecting, given that AI is uncontrollable, the uncontrollability that lets you release a virus and have it do so much damage, that same uncontrollability might make it very hard for you to write a defensive AI that you can trust. And that's not to mention the inherent easiness of offense compared to defense. Like I mentioned in a previous episode, if I want to kill a bunch of people, all I have to do is dump a bunch of energy in their vicinity. There's a lot of ways to get that right. There's a lot of ways to scramble their atoms that all accomplish the goal of killing them. So there's definitely a fundamental sense in which offense and destruction tend to be easier than defense and construction. But anyway, I think the biggest takeaway here is just how casual and ad hoc of an answer Arvind has given to quite an important question of what do you make of AI being a weapon? Moving on.
What do you think society's biggest misconception of AI is today?
I think our intuitions are too powerfully shaped by sci-fi portrayals of AI. And I think that's really a big problem. This idea that AI can become self-aware. When we look at the way that AI is architected today, that kind of fear has no basis in reality.
What's so hard about being self-aware? If you have a system which is capable of knowing things and understanding things in general, it's not much of an extra step to then know and understand things about itself, right? It's kind of a special case of just knowing things. Here, watch. I'm going to pull up GPT right now, and I'm going to ask it, hey, when I feel like someone is typing back to me in this chat box, what is really happening? Okay, GPT's answering, when it feels like something is back to you in this chat box, it's actually me, an AI, generating responses based on the information and context provided by your messages. Here's what happens behind the scenes. Message processing. When you send a message, it's processed by my underlying AI model, which analyzes the text to understand the context, meaning, and your needs. Response generation, blah, blah, blah. Typing simulation. The responses are then displayed in a way that simulates typing to make the conversation feel more natural, resembling human interaction. Everything is computed and automated with no human involvement. I'm designed to provide you with accurate, relevant, and helpful responses as quickly as possible, aiming to create an interactive and engaging experience. So, I would call that self-awareness. I can ask it a wide variety of questions that have never been asked before, questions that have never been directly trained. You're not going to find these exact questions in any data set. And it's going to give me correct answers talking about itself. Why is Arvind using the term self-awareness as if that's something that we're not already seeing in the AI models? maybe he means it in the broader sense of situational awareness, like knowing every relevant detail about its place in the world. But I think even then the bottleneck is not becoming more aware of the situation per se. I think it's just kind of reasoning more robustly. But even situational awareness, I don't think is a good two-word description of what it is that today's AIs are lacking. I always come back to that term robustness of like, it seems like they kind of can do everything, but then they're pretty quick to mess it up after a little bit. That's my sense of what AIs can and can't do, expressed in a short way. So when Arvind says, the fear that AI can become self-aware has no basis in reality, what is he talking about? AI is right here getting a pretty good understanding of itself. So again, at best, very imprecise language here by Arvind. I think maybe what he means is he's conflating a lot of doomer claims, like doomers claim that instrumental convergence will eventually have us seeing agents that are power hungry, that refuse to let themselves be turned off. And I think in Arvind's mind, he's kind of conflating it into a big single mass where it's like, okay, it's the Terminator and it's evil and it's self-aware and it's conscious and it has feelings and it has qualia and also it wants to seek power. Like, I think in his mind, he hasn't really untangled all the different concepts relevant in the doomer claim, but he's gotten himself to the point where he's saying this term self-aware and acting like that's this unachievable milestone from AI, when I think it's pretty accurate to say that AIs are pretty self-aware these days. And then finally, when he accuses our intuitions of being too powerfully shaped by sci-fi, what exactly is wrong with sci-fi about AI? It seems like a lot of the different ideas that sci-fi authors came up with are perfectly reasonable when you start making AI that's actually smart. I mean, first of all, the chatbots we're talking to today, HAL, or if you watch that movie, Her, I mean, Her is very similar, right, to the new GPT-4o. I mean, in fact, Sam Altman is getting sued by being too similar to that movie, right? I mean, a lot of the way that people imagine talking to their AIs is literally coming true. And things like virtual reality are literally coming true. What is wrong with sci-fi as a guide to what's about to happen? I mean, these things, as long as they're not logically paradoxical, sci-fi tends to be pretty plausible. In particular, the idea that you're going to have a superintelligence because the brain has a very finite capped level of intelligence, totally plausible. I actually don't agree with the general claim that sci-fi is shaping our conception of AI too much. I think that when people watch The Terminator, for instance, that's sci-fi, and that's a pretty good intuition for how dangerous and how powerful the AI is going to be. The fact that the Terminator can show up in a police station and just gun down successfully like the whole police force and then continue on its rampage, well, AI is also going to be kind of powerful like that. It's not going to be easy to shut off at all, right? A whole police force won't be a match for it. So movies tend to be on the side of good futurism compared to people like Arvind. I would much rather point you to James Cameron than Arvind based on what I've seen so far. Well, that's as good a place as any to wrap it up. I did abridge his interview with Harry Stebbings by maybe 40%, so feel free to go and listen to the whole thing. He makes a few other points that are more about like unemployment and basically more normie topics that I didn't think were that critical to hit on in the context of doom debates, because after all, existential risk is really the elephant in the room from my perspective, so I only focused on claims that have to do with that. Overall, I get that Arvind isn't a doomer, and neither is his co-blogger Sayesh Kapoor. I get that. But I've been pretty unimpressed with the way they go about making their case. Sayesh in particular, saying that P-Doom wasn't a good way to make policy, I thought was a really bad point, poorly supported, and I'm not alone in that assessment. And now Arvind, it seems like whenever it comes time to talk about the possibility of superintelligent AI, he just has kind of ad hoc responses compared to this elaborate framework that AI safety researchers are constantly diving into and publishing about, right? He just seems kind of dismissive of it, like, yeah, we'll get to it later. Regulation might not work. It's not a weapon. It just doesn't seem to me like high quality engagement. He seems committed to engaging in a way that sounds normal, in a way that he's going to get invited on a podcast like 20VC, which is meant for venture capitalists and startup founders. That's like a great niche for him to be occupying, right? Because people in that niche tend to just want to talk about business as normal. They tend to want to talk about the next quarter's profits and which stocks to buy, right? So it's a very normal framing of the situation. But the point of doom debates is to make it socially unacceptable to come into these podcasts and try to keep the whole thing normal. I'm sorry, it's not a normal situation when AI is closing the last remaining gap that we have to superintelligence, when AI is potentially about to hand off the entire era of control over the universe from biology to technology within our own lifetimes, or maybe the next generation. I don't think this is a normal situation. I don't think it's going to have normal consequences. I don't think it's going to be an S-curve that peters out at a convenient level, the way you seem to imply that it will, without arguing for it. If you want to support my quest to help raise the level of discourse in podcasts like 20VC that constantly touch on the subject of AI and could be touching on the subject of X risk, but keep doing it with the wrong mood, with the wrong questions, with the wrong perspective. If you want to support my mission of raising that level of discourse, raising the sanity waterline, then what I'm asking you to do right now is smack that subscribe button on YouTube. Go to Apple Podcasts and subscribe there. Go to a forum you like. Tell people about the show. Link your favorite episode. Tell a friend about it. Open up your texting app and text 3 friends right now which episode of Doom Debates they might enjoy. Stuff like that is helpful. I think you know that'll help, and it's helping already because the show is actually growing pretty fast and the engagement is actually pretty high. But I'm impatient. The faster we get Doom Debates into a big podcast, that gives us the most time to actually influence the discourse, to actually attract these kind of high-profile names and get a first-person account of their views, to have me debate them one-on-one or interview them one-on-one, or to moderate debates between other high-profile doomers and non-doomers. Or to just put pressure on them to make them accountable to the question of like, hey, why don't you go on Doom Debates? Like imagine that a Joe Rogan or a Lex Friedman had an open invite to somebody like Arvind to come on his show and he was saying no. That would be a very weird situation that he's going to feel pressure to wonder why isn't he going on those shows. That's where we need to get Doom Debates or some kind of forum like that. Before the world ends, we need the social infrastructure to have those kinds of discussions be socially expected. Let's just try to hurry it up and get there. That's it for today. Thanks for listening, and I'll see you back here on the next episode of Doom Debates.